I'm standing next to a Frenchman who used to live in California, who now lives in the UK, and he wears a St. Pauli jersey. That's international, huh?
Pretty much, yeah.
So thanks again for coming back, and I want to make sure that I properly introduce you. If somebody sees you, Nicholas, they should not call you Nicholas, right?
No, Nick. Nick if you're English speaker, or Nico if you're French speaking.
Yeah. Well, thanks for being here. We'll hear a lot about self-healing clusters, game of nodes, and scaling thrones. One fun fact that you told me earlier, when you got on stage, you said, holy shit, when you gave a presentation in Vegas, the screen wasn't as big as here in Vienna. So sometimes size really matters and impresses. I'm pretty sure it's not only the screen size that will impress people, but also your presentation, right?
Yeah, apparently the size does matter when it comes to screens.
All right, the floor is yours. 25 minutes, 5 minutes Q&A. Off you go.
Okay, thank you. Thanks very much. So yeah, thank you for having me. And for first, I'm very impressed by the venue. So I think that's really a good start for you guys, and I really hope that we'll even have more people next year. What we're going to take a look at today is really about making your cluster more resilient, adding stability, and this is really a fight to make your cluster more balanced. When I started looking at Kubernetes a long time ago, I came from a VMware background, and I don't know, how many of you knew about VMware DRS? A couple of you? Yeah, a lot of you. So a lot of still VMware people here. I was really surprised that with Kubernetes, we don't have this dynamic resource scheduling capabilities. Like Kubernetes is very dynamic as a platform, but there's no way for the scheduler to do things dynamically. Once the pod is scheduled for life until some events happen. And there's also a second thing I was quite intrigued with is we all know that Kubernetes is now the de facto operating system for cloud. However, Kubernetes has way to signal errors or any events into your Linux distribution, like your logs, into services, you can just check the logs. But how about the opposite, right? If we say Kubernetes as a whole is an operating system, how can the underlying OS, your Linux system, signal events to Kubernetes so that it can take actions? So that's another sort of issue we're going to try to address today, because until I've discovered some tools, there's no easy way to do that. So yeah. I'm going to try to go very quickly through the slides because it's mainly demos. I don't have any backup of, I don't have videos or anything, so I may fail. Don't laugh. I can laugh about myself, but don't laugh about me. All right, so who am I? My name is Nick. I'm heading the DevRel team at Spectral Cloud. I've been working with Kubernetes for the past 6 years, mainly with engineering team, doing DevRel, product management, and technical marketing as well. And what else? Yeah, I like running. Last time I was in Vienna was for the Vienna Marathon back in April, and I DNF, which was bad memories. So when I landed, I was a bit sad because it remind me of bad memories. But I'll come back next year, and this time I will finish and not get injured, hopefully. Okay, so a quick agenda for today. We're going to just check quickly the challenges for around Kubernetes cluster. What you should pay attention to, what is, how it grows, and what are the different challenges you're going to face over time. Then the heroes of the story, our battle, and then we'll go through a demo. Hopefully it's going to work. So first off, stability is key for Kubernetes, because now that Kubernetes is mature, right, even though we all know it's still a complex system, it's mature enough to run mission-critical applications, things like AI, ML workload, medical imaging. I'm working for Spectral Cloud, so our sweet spot is sort of edge, and we have a lot of customers in the healthcare environment. We have customers who use Kubernetes in drones to harvest fruits, for example, in big fields. So a lot of things are depending on those applications. Now, some applications are directly formatted in terms of the form factor into Kubernetes cluster. So like my application equal my Kubernetes cluster. This is the new form factor, for example, in planes, as I said, in drones, in some medical equipment. So they are actually Kubernetes cluster. And as the cluster grows, stability may become a challenge. The more nodes and pods you add, then potentially the more contention you're going to add, and also it may lead to performance issues if you don't implement any form of auto-scaling, right? As soon as you have to perform things manually, then you need to have complex system in place, monitoring, ticketing system, some sort of automation. So quick question, how many of you are using auto-scaling any auto-scaling tool as part of Kubernetes? All right. So the first thing that really struck me when I started to play with auto-scaling is that by default here, right, we have, we don't see the laser, but last line, if you don't set any requests or limits, by default, all pods will be best effort, which means that when you have resource contention, the scheduler is going to randomly kill pod in your system. But the thing that is difficult is how much requests is needed for your application, right? So this is something that is challenging, and this is a prerequisite for auto-scaling, whether it's VPA, KCD, HPA, all of that requires you to have proper request and limit in place. So this may be a challenge. And what makes a cluster unstable? So as already mentioned, pod eviction, when you have low node resources, obviously resource quotas, again, if you have not the right size for your quotas, not the priority class that are corresponding to that, then you may need to some disruptions, right? Because probably, I don't know if you're aware, but there's many different ways to set priorities in Kubernetes. So we just seen best effort, guaranteed, burst, all of that are quality of service, but orthogonal to that, we have priority class, right? And the two can work together or cannot, depending on how you configure it. And this is very confusing. Like, even talking about it, I'm confused. So it requires some extra work. And the more pods you add, the more nodes you add, it tends to get more complicated. Another one is network policies. If you start to play with network policy, then it's very easy to cut the branch that you're sitting on, all right? So you may also lead to network issues and application not being able to talk to other tiers or to other microservices. Another one is when you start adding stateful applications. So I don't know how many of you know what happens when you have a stateful application and the node dies. A couple of you? Yeah. Well, what happens? Nothing, right? Nothing. It's not going to be restarted automatically onto another node, so which requires some sort of manual action. And if you don't have like CSI replication, then you may be in trouble. Then you may want to consider a CSI that do synchronous replication and present the volume remotely to other nodes, et cetera, et cetera. So you're getting more layer of complexities to make the system highly available. And finally, login and monitoring. It's very easy to miss some alerts that you need, and some of the errors may completely be hidden somewhere, and you don't know what's happening because it's not in the log. Then you start this journey of troubleshooting, jumping from one container to another, causing delay in your how you're going to solve the problem. So that's a lot of potential problems in Kubernetes, right? So it's over time. When you start small and build on top of that, then you should be all right and discover one problem after another. So what are the building blocks to work around this? So first, try to automate the monitoring. One of the tools we're going to see today is the node problem detectors for real-time health checks. And I was talking about a way for the operating system to signal things to Kubernetes. This is one way to do it with the node problem detector. We're going to see how it works. Prometheus for metrics collections, using Prometheus plugin for HPA and KCD, that's also with the custom metrics API, all those kind of things. is really something that is useful. So I will always suggest you to take a look at that. Jaeger for application tracing or other CNCF projects. Then in terms of resource management, so this is Discheduler. So the Discheduler is to Kubernetes what DRS is to VMware, except that is not included by default, right? You have to install it yourself and create all your policies. Then, of course, we have VPA for optimizing resource allocation per pod, so more like setting the resource and limits. So one quick advice here, one tip. If you don't know how much request and limit is needed for a particular application, run VPA in off mode, which means recommendation mode, and you will have the recommendation within the pod status. So if you kubectl describe your pod after some time and you have enabled VPA in off mode, then you will see the new recommendation as part of the pod status, and then you can set the request and limit to that values the next time you restart the application during the maintenance window. KCD for scaling to 0. So I don't know how many of you are familiar with KCD? A couple of you. So KCD is great. It's like a layer on top of HPA, and it's triggered by event. So HPA is mainly leveraging CPU and memories, so resources. KCD leverages event. So for example, you could say, I've got a Kafka message queuing, and let's say I want to scale the number of consumer pods when my lag threshold is above 10, which means that you have 10 messages waiting for the consumer to consume them. This is what you can do with KCD. So extra things to save costs, right? KCD can scale to 0, meaning that when the pod the application is not used, it's scaling to 0 pods and then back again to the proper amount of pods when it needs it. And it's using HPA in the background, so it's kind of one layer on top of HPA. So this is why I didn't mention HPA here, is because KCD is just better and it's driving HPA. And of course, cluster autoscaler, which is the third component that we are going to see today to adapt the cluster size depending on your needs. For policies, of course, we have OPA. I mean, OPA. It's always fun to say this when in a German-speaking country, because my grandfather was OPA as well. I'm from the northeast of France, so we have this patois kind of speaking. So OPA was my my grandfather, right? So a long time ago. So Kyverno for policy validation, mutation, certificate validation, container signing validation, all of this, you should have this by default. Like Kyverno is one of the first things you should install in your cluster, and just to protect it from unsigned images. That's the very basic, install Kyverno by default. And then advanced logging, I've got 5 minutes left. Oh, you made like, yeah. Okay, so I need to jump to the demo very quickly. And then for advanced logging and observability, use Grafana, use Prometheus, all of this should be part of your default stack. So the heroes of the story. First, the three-eyed raven, which is the node problem detector I've mentioned. So how this guy works? So it's run as a daemon set. It leverages the native event and node condition within Kubernetes, so Kubernetes event and node condition, to report problem to the API server, right? So the event is a native object in Kubernetes. The node condition, it's a field that you can, just kubectl describe within your node. So the event will be used to describe temporary or less severe issues, so transient sort of issues, and the node condition is more persistent or server state of the node, like not healthy or something like that. It also defines exporter to report problems to other backends like Prometheus or Stackdriver if you're running in Google. So it's leveraging multiple subdaemons to monitor specific things. So system log monitors to report the kernel deadlog node condition. It can generate things, like monitor HTTP, generate NTTP problem node condition, monitor metric collection, and also health check on kubelets and report, node conditions such as kubelet and healthy. So very useful to report from the underlying OS into your Kubernetes API server so that you can take action. We're going to see what we can do once we have these errors. Then the second guy, the hand of the king this time, is the scheduler. Hopefully this guy going to not have his head removed. So the scheduler by default doesn't evict pod for rebalancing purpose, right? It's not possible. So the scheduler will do this job based on policy to prevent bottleneck and to enhance cluster efficiency. In the demo, I'm going to show you a couple of options. But by default, the configuration is good enough to rebalance your cluster and act upon certain errors. So it can be run as a job, cron job deployment. You just choose it as a deployment type when you install it via Helm or customize or static manifest. So a couple of policies you can implement. Low node utilization, which means that you want a low node utilization, which means that when it's exceeding a particular threshold for one node, it's going to rebalance to spread the pods across your cluster. We also have high node utilization, which is kind of the opposite. We want high node utilization, which means that any node that has low utilization, those pods will be rebalanced to a fewer number of nodes to improve the cluster usage. So we have removed duplicates to kind of spread the number of pods of a particular deployment into as many nodes as possible. And another one, you have other things here, and another one that is very interesting, it is remove pods violating node taints. So this one is very useful because it can be combined with the node problem detector and the cluster autoscaler to automatically remove nodes which have problem. So NPD will have, as I said, it's going to play with the node condition. And if the node condition becomes to be, it's going to taint the node, typically with no schedule, then the descheduler can evict the pod for a node that has the taint no schedule. But it's only limited to a couple of things that NPD can detect. So I've checked on the GitHub repo. There are certainly, there's already a PR to make it more customizable so that NPD can report it can taint the node depending on more conditions. But today it's just a few of them, like PID pressure, memory pressure, disk pressure. So all of that will trigger a taint into your node with no schedule. And as soon as it's no schedule, then the descheduler can evict the pod, right? But the condition has to be the taint with the action no schedule. And then cluster autoscaler, it can, as the name stands, you're probably all familiar with that one, dynamically adjust cluster size, adds or remove nodes from node groups on demand. And it's mainly used with cluster API, or we're going to be using Google here, and GKE is installed by default. It's just a box to tick. So typically, how you would use cluster autoscaler within a cluster API environment is just, you have multiple stack with cluster API. Typically, you want Argo CD for the declarative way, the GitOps approach to deploy your target cluster. You want to have something like Cluster API add-on provider Helm, which is a Helm proxy to install software to your target cluster. So you're running a Helm proxy on the management cluster, and then you set the destination cluster configuration so that Helm can, this software can act as a proxy to install software in the target cluster, like the CNI, because I don't know if you're aware, but if you're using Cluster API, by default, you won't have a fully functional cluster. You need to install the CNI. And you can use that software to install the CNI. And then you add cluster autoscaler on top so that your destination cluster will have cluster autoscaler enabled. And for this, cluster autoscaler is just running as a deployment. You just have to specify one thing, which is here how you want cluster API to be configured and which destination cluster it has to manage. So in that particular configuration, I'm going to be monitoring KCD cluster, which is a destination cluster. So what that means is that I need one deployment per target cluster. Right? That's the only, if you want to automate that, this is the only thing you need. One deployment per target cluster. and then you discover the cluster name, and then a cluster autoscaler will be directly installed into that cluster. Job done. Very easy. And of course, in the destination cluster declarative configuration for cluster API, which is machine deployment for your cluster, you just annotate it with a minimum size and maximum size, right? As easy as that. Okay, so now let's jump into the demo. We're going to try to do all those things in 10 minutes. So maybe I will skip a couple of things. So the idea is to make them work together. So that means have cluster autoscaler kick in. So that is going to trigger more nodes. And then when more nodes are added, we will have the descheduler evict in pods so that it can rebalance them across the new nodes. We're going to test also NPD. So NPD is quite tricky to test in real, like in real way of doing it. So we're going to just write into the kernel messaging file so that NPD can detect the event. And the last thing I wanted to show you is manually taint a node as no schedule, which kind of simulate what would NPD do if it notice a particular problem, and the action would be taint the node. So typically here, this scheduler will evict the pods from the node that has the no schedule taint, and cluster autoscaler will kick in to create an additional node. So let's get started with this. So here, I need to remove this. All right, so this is my cluster. For the moment, I have only, everyone sees this? Yeah, good. So I have currently one node. What I want to do is go to pod in my default namespace, ns, default. I have no pods. So first, I'm going to kubectl apply some high CPU deployment, which is basically this one. So 800 mil CPU. So you can see here, I've got, the cluster is happy. I've got a single node, but no pending pod. Let's start to increase the size of the deployment. Edit the deployment, go to replica. I've got 3 replica. Let's make it 7, right? Okay, so now I have pending pods. So what that means is now I should have cluster autoscaler kicking in. So in the meantime, I'm going to just show you the configuration of the cluster. I'm running on GKE here. And if I go into where is it? Not engine. I want to go to Kubernetes. Here. Nodes. Edit. To provisioning. So I've got my autoscaler that is enabled there. I think you enable it at the node pool level here, default pool, edit, and it's just a box to tick here, right? Enable autoscaler. So you don't have to install it when you're on GKE. And it's the kind of the same thing with other cloud. So there's you can either use Cluster API as part of a cloud provider, or using Cluster Autoscaler as part of a cloud provider, or integrated with Cluster API. So now what you should see is the size of the pool getting increased and have more nodes coming up. Yeah, you can see I have 2 nodes now. So I should be good. So container creating, so we have, if I go to nodes, I have 2 nodes now, right? So now let's increase the size again, because we can see if you look at pods that we have, yeah, it's pretty, if I sort by node, it's 3, 4, and 3, so it's fairly balanced. Now, as I said, the scheduler is running as a cron job, in my case, it's pulling the state of the cluster every 2 minutes. So every 2 minutes, we'll have a job running. And if you go to the logs here, you can see that it's starting the different policies, and then it's going to say, okay, do I need to evict pods or not? So here doesn't do anything, right? So now let's deploy more. This time low CPU. Okay. And let's increase the size of the low. So we have 3 replicas. Let's try to increase to 17, right? Okay, so again, we have pending state, and you can see here it starts already to terminate some pods, which means that it's certainly kicking in already. Shutting down, duplicate, evict pod. So you can see here the message is it's starting to evict pod to make the cluster more balanced. And this is exactly what we need. This is what DRS would do for VMware. So it's actually working. So now we're going to end up with, again, another node, hopefully. And if we check the status of the pod, yeah, still pending. So it's going to create another node. In the meantime, I'm going to show you the configuration of the descheduler. So it's configured via a config map that is mounted as a volume. And if I just look for, descheduler here. So this is the configuration. So descheduler policy, as I said, low node utilization, enable true, then you give the parameter, the different threshold. Then other options is just enable or not in terms of the policy. So I want to remove duplicate, yes, no, remove pods having too many restarts, remove pods violating interpod anti-affinity, node affinity, all of things. And the one we want to test is remove pods violating node taints. Okay, so let's test this one, and we should be good. So we have 3 nodes still, pods pending. No, okay. So we have, again, node descheduler is kicking in because we can see all the pods terminating. So now let's just taint one of the nodes to see what's going to happen. So let's try to taint maybe this one, the one in the middle. Okay, so to taint the node, kubectl taint, I got here just the node, not the dash at the end, which is to remove the taint. If I do this, let's check describe. You should see in the taint, what? QVS2, QVS2, describe, taint. Where's my taint? Yeah, so now I've got my taint here, and as a result, I should see during the next cycle of my cron job, something should happen. Yeah, it's 120, so let's wait for 20 more seconds. Almost on time, I've got 1 minute left. So far it worked, I'm very impressed. I thought like it's gonna be a mess, but actually it's sort of working. Okay, 10 more seconds to trigger the new one. In the meantime, do we have any new node coming up? No? So let's check. Okay, so what does it say? Oh, yeah, he's not happy. If I check for taint, so not all taints with no schedule effect, so he's going to start to move things around. And if I check the pods, so remember the nodes, it's QVS2. So you can see that now all the nodes, all the pods that are with QVS2 were terminating. So effectively, we have this scheduler that is acting upon the no schedule. So here I've done the no schedule manually, but typically that would be NPD that would mark and taint the node depending on certain events I've mentioned, like PID pressure, disk pressure, all that. Okay, so that was it for the demo, and just the key takeaways, I would say. Okay, key takeaways for today. So first, stability is the cornerstone of a resilient Kubernetes cluster. The 3 tools that we have seen today, I think, should be part of every single cluster by default. If you have any provisioning tool, it should definitely be part of that. Node problem NPD, node problem detector, disk scheduler, cluster autoscaler, each play unique but complementary roles. So be proactive, not reactive, by employing intelligent monitoring and rebalancing strategies. And of course, all of this is made possible because of the Kubernetes API. Node scheduler, the rescheduler is using the Kubernetes API, NPD is leveraging event, node condition, part of the Kubernetes API, cluster autoscaler is creating CRDs. So all that is made available because Kubernetes as a platform is fully extensible. And don't forget to combine multiple top-level policies in the disk scheduler to match all the use cases you may face. A quick hook into what we do at Spectral Cloud, of course. So what I've mentioned today can be represented very easily in our cluster profile, which is using Cluster API, as different stacks. So if you were to go to Spectral Cloud, dashboard, you would be easily able to create NPD, cluster autoscaler, everything as a single layer, and make this super repeatable. If you want to test it out, this is the QR code. And that's me done. Thank you. 2 minutes. But I don't know if there's any questions.
Big round of applause. Unfortunately, you're easy to spot with your orange jersey. So in case people have questions, we will probably do them here or later down in the hall. But we are officially out, and we want to also get the next speaker in who actually gives us some insights into the Kubernetes code to explain some of the things that actually happened, what you've explained today.
Great.
Thank you so much. And we are skipping the official Q&A again. If people have questions, just here or downstairs.
You can catch up with me just there if you want. Thank you again.
Thank you.